So my name is Ian Davies and I'm the Head of Curriculum at White Rose Maths, and along with the Head of White Rose Maths, Caroline Hamilton, I'm one of the series editors and authors of our new Key Stage 3 textbooks that we have produced in partnership with Collins that I'm going to talk through this afternoon. So firstly, to just give you a flavour of who we are, this is the whole White Rose Maths team. I'm the handsome looking fellow down there, but you can see we're quite a large team. We've been working in the primary sector for quite a long time, and we're very renowned, I think, internationally for the work we've done with primary curriculum. And in the last 3 or 4 years, we've been expanding heavily into secondary as well. And so there you see our team of primary, secondary, early year specialists, and all our admin people that help us run White Rose Maths as well. So what we provide is we provide materials to support teaching the curriculum right through from reception, which is 4 or 5 year olds here in the UK, right through to year 11, which is 16-year olds. For all of those year groups, we provide completely free schemes of learning with ideas of how to teach and deliver the English Mathematics National Curriculum. Okay. Alongside that, we've also got a Year 12 Gcse resit scheme, and alongside the scheme, as well as the teaching ideas and the content in there, we provide things like assessments for the end of each term. We provide assessments for each block of learning, and we provide some interactive materials as well that you can use in interactive whiteboards to support the teaching of the schemes. And all of those are available completely free on our website to help people really achieve our mission, which is for everybody to succeed in mathematics. So maths everyone can is our motto, and it's our firm belief that whatever your starting point, you can become better and better at mathematics, provided you're taught it in a way that is going to help you to understand and learn maths. So we believe everyone can achieve, and everything we do is set out to help realise that aim of every teacher being a world-class teacher of mathematics and every learner learning and succeeding in mathematics. We also provide a set of premium resources to support our free schemes of learning. So these basically provide some additional practice alongside the schemes, which are focused more on teaching. So they're teacher facing, whereas our premium resources are then student facing. So for every single small step in our schemes, we have a double-sided worksheet. One of them is illustrated there. We also at secondary provide things like true or false questions and starter activities, which we call Flashback 4, which help with interleaving and revisiting topics to make sure that learning is secure. We also provide training, and we provide training in several formats. We used to provide mainly face-to-face training, but obviously with the pandemic, that's been more difficult. So our face-to-face training, we have delivered mainly in this format as Zoom webinars for the last year and a bit. We also have online training. You can see one there in the bottom right-hand corner of your screen, where you can watch the training in your own time at schools, and they explore the same aspects as our face-to-face training and our webinars, how to best deliver the White Rose Math schemes and to lead developments in the teaching of mathematics. Also, when the pandemic started and England and the rest of the United Kingdom went into a big national lockdown, children were learning from home, so we changed what we were doing and did an awful lot of support for home learning. And there's basically free videos on, again, every single aspect of the small steps that we teach in our curriculum. So those can be used either at home or with small groups in class, and they tie directly to what we're teaching in our curriculum. So ready to support learners in whatever environment they are working in at a particular time. So a lot of teachers found that an immensely valuable resource when schools were closed, but they can also be used as well within schools. It's not just for when schools are closed as well. Okay. And those, by the way, do come again with teaching slides that you can use and adapt to your own learners. So the videos are free and the teaching slides you can get from our premium resources. So in terms of our reach nationally and internationally, well, we've got a huge social media following to start with, over 100,000 Facebook users, more than 60,000 Twitter users, and 20,000 on Instagram as well. So, you know, we're very, very well known nationally and internationally. Within the UK and internationally, over 20,000 teachers a year have been receiving some form of our continuous professional development, again, mainly through online in the last year, but through face-to-face training as well. We estimate that more than 80% of primary schools in the UK and around about 40% of secondary schools are making some use of our resources, whether that's been using our schemes or our premium resources or both. So that secondary figure is continuously growing. We started the secondary scheme only 3 years ago, so that's, you know, relatively new, but we've already got to about 40% of the market in the UK with that. And in terms of the home learning videos I was just discussing, just in January this year, there were 14 million downloads of our home learning videos, which kind of really emphasizes how vast our reach has been and how important we've been as a lifeline to support teachers nationally and internationally during lockdown. A real big challenge to keep our servers and our website going with the amount of traffic we've had in the last year in particular. So looking a little bit at the schemes in detail, just to give you a bit of background to the textbooks, what we're trying to focus on is building a real deep conceptual understanding of the mathematics that students are learning. It's not just about following procedures and using procedures, but it's understanding how those procedures work so that they can apply them in a variety of different situations. We're looking also at making those connections between different concepts very, very explicit. Quite often in a lot of more traditional maths approaches and maths textbooks, you see things really sort of separated into different blocks, whereas we make the connections between blocks really specific. So when we're looking at trigonometry, for example, at the end of Key Stage 3, we're making big links there to ratio and the idea that these are trigonometrical ratios. When we're studying ratio for the first time in Year 8, we look at the link between ratio and gradient, for example. So again, making the point that proportional reasoning is a key thing for understanding mathematics, and making these connections explicit to help develop and deepen that student understanding so that they can succeed more rapidly in mathematics. It helps them to make sense of the maths, and it's not just making sense by looking at, you know, real life examples. We will do that, of course, but making sense of the mathematics itself, the underlying structures within the maths, so that they can apply their math skills in all sorts of different areas. We try to address both fluency and retention as well. A lot of people, if they're trained to do a certain mathematical technique, can do it at one point and become reasonably fluent, but sometimes will forget it. So we really look carefully at how we can ensure that there is retention by interleaving the mathematics, bringing it back in different areas so students see it again and keep those connections in their brain fired up. So really based on that cognitive research there. Another really good way of doing that is to ensure that you've got a good amount of mathematical discussion going on in the classrooms. So our schemes and the textbooks that are based on our schemes really promote a lot of teacher questioning and student talk. We believe that that talk is the start of reasoning, and once you are able to reason mathematically, then you are able to tackle an awful lot more of that mathematics, and that's one of the ways of breaking in and making sure that we get that success. That's what our end goal is, to really get students who can think independently and reflect on what they've done. Then when they're able to reason, they are also able to solve problems in whatever new, different context they are presented to them. So what our schemes look like, for each year group, we have a plan like this. This is our yearly overview. We can see it's split into the 3 terms, which is the main way that we study here in the UK. And each term is split into 2 half terms, which again is split into separate little blocks of learning. Okay, you can see that these blocks are quite long, and then traditional scheme of work, that we go back a few years ago, you might spend, a few lessons on this and a few lessons on that, a few lessons on the next topic, without really studying anything in depth. But we look at each thing for a couple of weeks at a time. For each of those blocks, if I take that first one there, that's sequences, then we give this series of small steps. This is what we will be learning within that block. And for every one of those small steps, we then provide some resources the teachers can use to teach those particular small steps. So there's some notes and guidance, what the key vocabulary is, what key questions you might want to ask students after they've done the learning, and also some exemplar questions, some things you might want to use within the classroom for the teaching of this particular step. And I'll explain those small steps a little bit more as I go on through the presentation. The idea for them is that rather than taking one massive objective like equations, we really break it down into a series of small steps so that you know that every aspect of an objective has been examined. There's nothing left to chance. There's nothing that has been left out of the curriculum. It really focuses in closely on exactly what we want the students to be thinking about at one particular time, so that they can build up their journey through mathematics step by step, related step after another related step. Also important in this is that a small step is not necessarily one lesson, because you'll all work in different schools with different lengths of times of lessons for a start. Some lessons are 35 minutes, some are an hour or even 2-hour lessons. So sometimes one lesson could be several small steps, or one small step might last on 2 or 3 lessons. A lot of that will just depend on your own situation and what particular group you're teaching, whether they can grasp something very, very quickly, or whether it's something that you want to look at in even more depth. So here are the small steps for one of our blocks that we'll be looking at in some detail later on, which is the equality and equivalence block. You can see that we start really with just that notion. What do we mean by equality? What do we mean when we say that 2 things are equal to each other? It's something I think that a lot of schemes don't look at in depth. It's just assumed that students understand what equality is. Well, we don't make that assumption. We have it there as a step and really explore that idea. You can see also that when we come to doing equations, which is obviously an important part of the equality step, that we split that up into firstly, 1 step, linear equations involving addition and subtraction. And because they're closely related to each other, we've got them in that 1 step together, and how we make that link with using inverse operations to solve those equations. Going a little bit further down there, we look at understanding the meaning of like and unlike terms. Something we just again, gloss over and don't go into any depth, but that then leads to problems in the next step. You can't really understand when two expressions are equivalent if you haven't really got the idea of what like and unlike terms are. So again, we provide ideas and things that the teachers can use to support and assess as well. Do students understand that step, the meaning of like and unlike terms, which means that they can go on to look at equivalence and go on to the last step there, looking at simplification. In a lot of schemes, perhaps you'd only have that last term. You go straight to simplifying without thinking of these constituent parts that you need to support that learning. Okay. So now I'm going to go over into an overview of the textbook and how that works and how it links to that structure we've got in our schemes. Firstly, it's a series of 3 textbooks because Key Stage 3 is meant to cover the first 3 years of secondary education here in the UK. So book 1 that covers our year 7, which is for 11 and 12-year-olds, was released in March. Book 2 was released yesterday on May the 10th, and book 3 will be coming in September as well. Okay, so that's book 3 is written, it's in its final printing stages at the moment. It will be released in September. So that suite of books will then cover everything that's in the United Kingdom National Curriculum for Key Stage 3. What they do is they build on our schemes and they provide a learning journey that again focuses on that notion of deep understanding of concepts so students become competent in using mathematics. Although it's designed to fit exactly alongside our scheme, obviously it will fit alongside other materials and other curriculum as well, because the mathematics is very, very similar indeed. So if you have a slightly different curriculum from the UK one, you can probably still use these textbooks and our schemes of learning because the overlap is likely to be highly significant in there. We're also looking at using a mastery approach. There's been a lot of talk about mastery approach in the last certainly decade or so in the UK, mainly in primary, but in the last 2 or 3 years as well, also in secondary. So we're looking at supporting a mastery approach to teaching and learning that covers those national curriculum objectives. There again are the steps that I showed you from the equality and equivalence block in year 7. And if I take those first 2 steps in there, then those 2 steps are also the first 2 steps in the chapter we've got in the textbook there on using the equal sign covers those 2 steps. And there'll probably be 2 sections in that book, one about the first step in that chapter, sorry, one about the first step and one about the second step in there. So there's a direct link between the steps in our curriculum and the steps that are used in our textbooks, exactly the same things. What we mean by a mastery approach, for those of you that may not be quite as familiar with it, we're not talking about mastering something at the end of a lesson. There's often a bit of confusion with this where people think that, you know, you master something before you go on to the next thing. Mastery takes years and years in whatever field you're talking about, mathematics, sport, wherever. You don't become a master overnight. Mastery takes a long time and lots of purposeful practice. So we're doing that building on from those small steps as we're on the journey towards mastery. We support that and support the understanding of that by using a concrete, pictorial and abstract approach, looking at how things are in the real world, looking how we can represent that using pictures and how we can represent that mathematics finally in more abstract form. Again, at secondary, I think it's traditional to do an awful lot of the abstract without perhaps thinking about what these mean, how we can support it with pictures, or what the concrete experience of students would be to help them understand the abstract symbols that we use. So just as an example here, I've got 4 large multi-link cubes and 3 ones, and what that might represent is it might represent something that we could draw as a bar model and saying 4 lots of some number we don't know, that's called D. So each of the cubes is representing the letter D, and the number 3 at the end, represented by the 3 ones. And in a totally abstract way, you might see that written down as the expression 4D add 3. And we'll look at how we use that approach in the textbook in a little while. In order to support that, throughout the book, we use these symbols, which are the same symbols we use in our Premium Resources worksheets. Again, there on the left is our Premium Resource worksheet, and on the right is a page from our textbook. So we have a symbol here that's a cube, which suggests that they use some sort of concrete materials. We call them concrete manipulatives to help make sense of the maths. We could draw a bar model. I gave an example of the bar model before. You might want to draw a different diagram, so a pencil icon shows that. Questions where you want to think deeply about that provide more challenge, I'll give them with this little think symbol, and questions that are suitable for that discussion and that exploratory talk that I was discussing earlier, the idea of getting students reasoning right early on in the mathematical career at Key Stage 3 has got that little talk symbol for a discussion activity. So again, it's aligned fully between our Premium Resources and our textbook using those same symbols so students know what's expected. We also use variation within our schemes, and there's 2 main types of variation that we look at, which are conceptual and procedural. So for example, by conceptual variation, I mean, looking at the different ways we can represent an equation and what an equation means. An equation is, after all, a fairly abstract concept, but we can represent them using these part-whole models. A balance is quite a common model that people use for equations, and a bar model is just another way of representing it as well. And what we find is that when students are able to access these multiple representations of the same concept, it gives them a deeper, firmer understanding of what that concept is and how they can relate it back to something else, perhaps relate it back to cubes and counters or relate it back to a part-whole model to understand what they're doing when they're working in the abstract. Procedural variation, well, here's an example of that, where we're looking at how we've changed something in the question but kept something else the same. So really, again, focusing that student attention on what we want here. So we've got all these different fractions of 100 and then of 600, sorry, and then in the second part there we've got in question 2 noticing the connections between part D and part F. Now, those are the sorts of questions that we want teachers to be asking when they're using the textbooks. Sometimes they're there explicitly, but sometimes it will be implicit, and it will be in the teacher guide that we put this variation in. And here's an opportunity for you to make links and have discussions with the students. Well, what happens when I double the denominator? What happens when I multiply the denominator by 5, or I divide the denominator by 5? What happens to the answer to the question? And maybe support that again through drawing some pictures to see why the result happens. So within the textbook, you'll notice, if you're not familiar with our schemes, that quite unusually we start with algebra. Quite often, things always start with number, but we decided that for our curriculum, we're into Key Stage 3, it's a new thing for a lot of students, so let's start with algebra because it's fresh and it's exciting, something they haven't looked at before. There's very little algebra in the Key Stage 2 national curriculum in the UK, so it's something that when they start in secondary school, it gives them something new to look at. Also, it's really important that that block of learning that contains those 3 sub-blocks there is about algebraic thinking. It's not about tricks, it's not about procedures. We're looking a lot at sequences, but we don't, for example, in this book, look at finding the rule for the nth term. That's something we do in book 2 rather than in book 1. Okay, here it's really about thinking about sequences and understanding the difference between linear and non-linear sequences and really getting that firmly established rather than teaching a trick and then they try to apply that trick later on to a quadratic sequence where it's totally inappropriate. So again, really getting to understand what we mean by algebraic representation and to use it. particularly helpful at really leveling the playing field. Students comes in at all sorts of different levels of attainment at the start of year 7. So what we're trying to do then is give them all something new, all where they've got a new chance to be able to start to learn and enjoy mathematics again. What we strongly recommend, therefore, in that first block is that we get the calculators out as well. So they're not phased out by being unable to do the algebra and the substitution because they can't do the arithmetic. It's about the algebra, it's about thinking about the algebra, so use the calculators. It's also a great chance then to teach them the calculator skills as well that they will need later on. And if you're following, the UK Gcse system, 2/3 of the papers now are calculator papers. So students need to learn how to use calculators effectively. And I think the best people to teach them that are us as maths teachers. So using that algebra block to both build student confidence in something new and to be able to learn how to use calculators effectively as well. Okay, you'll notice that some of the steps have got a little H on them, and that just basically means it's a higher step. So we think these have got a little bit more stretch and challenge in them. So it might be that with some classes of some lower attaining students, you might not want to cover those steps in year 7. If you don't, that's fine. That material will come back in year 8 and come back in year 9. It's a very cumulative curriculum. So anything we do in year 7 is built on in year 8, is built on in year 9 as well. So there's another full section on standard form in book 2. So if you don't do that in book 1, that's fine. But if your students are succeeding and need a little bit more challenge, then they can start that certainly in book 1 if appropriate. So just a quick look now at what a chapter looks like and what a block looks like, and then I'll go inside the chapter in a little bit more detail. So we're split into these blocks, which are the same blocks as our scheme of learning, and the 9th block in year 7 is directed number. So here in book 1, block 9 will be directed number, and the first thing you get is an overview page like this saying what we will learn and giving the idea of some of the things we'll be looking at. That we'll be using number lines. We can use double-sided counters again as a really powerful representation to help understand how to work with directed number. Again, looking at bar models, making links again between equations that we did earlier on. That aspect of interleaving and bringing things back to help that retention is a key thing in our schemes and is certainly key within our textbooks in there. So you have that block overview, and then the block is then split into a series of chapters. And here's the second of the chapters in block 9, which is about adding and subtracting directed numbers. Okay, you can see there it's got the small steps that we're going to be addressing in this particular chapter. Some are you ready questions, are they ready to start this chapter, and an explicit look at those models and representations that they'll be using within this chapter. And again, I'll look at these in more detail when I go inside the chapter next. After that first page, we've got some worked examples showing how we can use the representations and the manipulatives in order to support the learning of adding and subtracting directed number, and then we get into some practice questions. And you can see within the practice questions there, we've got these symbols for the manipulatives. You could use manipulatives here. We've got the idea of the discuss questions in there as well. At the end of each practice exercise, there's then a little what do you think question with the think symbol, which are going to challenge the students to think a little bit deeper about what it is they've just been learning, and will often lead into what they're going to be doing into the next section of the chapter as well. At the end of each chapter, then there's these 3 sections: consolidation, more practice, some stretch questions, so deepening learning. So for those who may have found that well, perhaps easier, they could do some stretch questions, while those who needed some more support might be doing some of the consolidation questions. And at the end of each chapter then, also some reflection questions. So a little nod there to metacognition, getting students to think about their thinking, to think about what they've learned. And that reflection, again, really does help embed their learning and help them to remember what it is they have been studying. So that was 9.2. Then after all the chapters in that block 9, at the end we have this little block closer as well. There we give you what skills the students have been learning. So what the fluency, reasoning and problem solving has been involved in this block. So again, that links very much to the UK national curriculum of fluency, reasoning and problem solving being the 3 key aims. And some questions to check their understanding, to check that they've understood everything that has been within that block. Again, providing a little assessment for you as a teacher as to how well they've done and where you might want to come back to some things later on. So I'm just going to go through that idea of what's in the chapter now, just in a little bit more detail, looking at another one of the chapters in the book. And the one I'm going to look at is 3.4, the idea of using the equivalent sign. Again, we start with the small steps. So which small steps in the White Rose Maths curriculum does this address? Now, we could include an awful lot here. We're looking at the key ones that this chapter is focusing on. So really the main thing is equivalence and using the equivalent sign, but obviously that might involve like and unlike terms. Well, it will involve like and unlike terms as well. So we've mentioned that one, but we don't mention every single small step that it could be, just the ones that it is focused on. And linked to those as well, we've got the key words. Very important within our scheme of learning and within the book is the use of correct mathematical language and using the correct maths language, using the correct symbols. The whole point of this block is really distinguishing between equality and equivalence, and that triple equals sign for equivalence and the ordinary equal sign when two things are equal to each other rather than being equivalent to each other. So those keywords, again, it's not every single word that's mathematical that's in the chapter because that would be impractical, but the key ones for that chapter and what they mean. We then had this idea of the "are you ready" questions. And basically, are you ready to do the learning? Have you covered what you need to know before you can start this chapter effectively? So if students struggle with anything in this, you know you need to do some intervention before you go into the main learning. So for example, looking at our terms like or unlike, and we've thrown in there the sort of things that might easily be mistaken for each other. Students might think that these terms are like because they've both got 11 in them, or they might think these are unlike because they've got different signs, and both of those would be wrong. So really challenging their thinking there with those "are you ready" questions. It's not just simple questions, it's what do they need to know, and can you sort out as a teacher that they are ready for the learning to come. We then go into detail on why we've picked these questions in the Behind the Questions Teacher's Guide. So there it's telling you that the first 3 questions show whether they have the necessary skills with like or unlike terms to get the material in the chapter. And question 4 is there in order to think about, well, what effect do signs have? It may look like just some very simple arithmetic there, and indeed it is. But if you're not looking at the difference between where signs are on particular different terms in an expression, then obviously simplifying algebraic expressions is going to be complex as well. So looking at the signs there, getting them ready for what's to come. We then have the idea of the models and the representations that are used in the book for this particular set of steps in the chapter. So for the student, it gives them the ideas of what the representations mean. And for you as the teacher, it gives you the idea of what you might want to have available in your classroom, or what you might want the students to have available at home, again, if we're ever in a home learning situation again. Okay, notice that, you know, the symbols are covered as well as the objects. And again, in the Behind the Questions Teacher's Guide, we have the explanations here of what we're using. So we're using blocks, cubes, and you can use pencils, pens, whatever you want to represent numbers. Talking about algebra tiles, and again, talking about the abstract symbol as well. So it's not just about concrete medals, it's not just about pictures, it's about leaning and learning towards that abstract symbolic mathematics that we do want them to understand as well. We then have worked examples, and these go in some detail of what the students need to do. Before we can do that, simplifying by collecting by terms, we need to know that they are comfortable with algebraic notation. So for each part in the example, we have circled there what it is that we would expect to see as the students answer to this. Right, the question is equivalent to the answer, and then written out for them why it is we give the answer in this way. And again, we take that as far as we need to, looking also at conventions in mathematics. Q multiplied by P, well, you could write QP, but we tend to write PQ because we tend to write these in alphabetical order. So explaining to students how to do each part of the question and why we write the answers as we write them. Here's the next one for example 2, and this is where we now begin to do that simplifying. And for that first one there, we're now modeling how we use those models. So the idea is you've got a counter that's standing for P, which in its turn is standing for a number. So P add 4P add 2P, you can see then is represented by those counters, and you can see altogether you've got 7 counters. And straight away you've got rid of that misconception that P add 4P add 2P is 7PPP or 7P cubed or anything like that. You've got 7 lots of P. That extends then as the examples become more difficult, and we're looking at algebra tiles, we're looking at x squared there. Again, a very common error which we highlight here at the bottom of the page is to write 2x squared plus 3x squared is 5x to the 4th. And we can see that if you add 2 of those tiles to 3 of those tiles, you've got 5 of the same tiles. So the answer is 5x squared. And again, that highlighting of misconceptions both within the worked examples and in the teacher guide is a key aspect of the book that supports the teaching and learning of mathematics for that deep understanding that we want. There it is again in the teacher guide. So we say things that you might want to look out for as a teacher, what things might go wrong. And quite often we say some ideas of what you might want to do to stop that going wrong as well. We also point out the really important ideas about interleaving opportunities. What other things can we revisit here, or when will we be revisiting them again? To again support that idea of retention and deepening understanding through revisiting in the different topics. So highlighting for teachers where we will see this topic again and what you might need in order to do it in the first place. Then we go on to that practice section, and again you can see there that this is just the first page of it. There's an awful lot then of practice using the skills that we've just been learning in the same order as the examples. So firstly question 1 about the notation, and question 2 looking at simplification, and by question 3 notice we've got students thinking and reasoning here. What are these, which of these expressions that are equivalent to 4m, and by association then which ones aren't? So really getting to discuss and think about what those mean. And again, in the behind the question section, we're looking at questions 1, 2, 3, what it is we're trying to get out from these questions and how you might support them. With that number 3, if students are making error, well, we're suggesting perhaps you can use substitution as a way to highlight which expressions are equal to 4m and which ones aren't. So just some ideas of how to approach this in the classroom. Then we go into the next section, and again, as you can see, as we're getting further on, there's more and more of that idea of reasoning being developed within each bit. So for this question 6, you can see there's an awful lot of wrong answers. Again, challenging misconceptions, making sure students can see why these things are wrong. Really getting the students to think deeply about the mathematics rather than just giving them a load of examples that are all the same as each other just to find out some answers, but really doing that mathematical thinking in there as well. Important, I think, to say there that the reasoning activities are for everybody. Okay, so they're in the main body of the exercise there, right early on as well. As early as question 3 in this particular one. It's not something that's left at the end just for the high attainers to look at. We want everybody to be able to succeed in mathematics. We want everybody to develop their reasoning skills. At the end of each section, there's the what do you think section, and quite often here we have two characters talking to each other. You see a lot of this in the books, just to get the idea of those discussions going there, just to challenge the students to think about it. Very often this will lead into what we're about to do next, or into other areas of mathematics, but definitely there are things that, you know, through the talking heads of the characters, get them thinking about methods, getting thinking about what's the same and what's different about the way we represent things. Again, within the behind the questions, we cover that in detail. What was it we were thinking about there? And in that first question, why is it with 0A, we don't write the letter, we write 0, but with 1A, we don't write the number, we write A. And why these things are conventions, which ones are the matter, which don't matter. Really, you know, get into grips with the sometimes idiosyncratic nature of mathematics in there. Okay. So that was the first part of that section. Then we move on to that simplification with a little bit more detail in the second part of the section. And again, you can see there, we're modeling how you would use the concrete resources or the pictures to understand this simplification. You've got a different thing standing for A, B, and C. And we can see here why it's called collecting like terms, and you can actually physically collect the objects together, which ties into the abstract idea of what you write in your book here of collecting the like terms in the algebra. So we're developing the skills now as we go into this second part of the chapter. And after that, we get another section. You can see in that first question there, there's a lot of variation in there, but you can also see there's a manipulative sign chain. You can use the manipulatives to help them understand something standing for A, something standing for B. And also notice that we're looking at adding the number 2 as well. So it's not just letters, but sometimes students make mistakes then when it's letters and numbers. So straight away we're looking at what's the same and what's different if we're collecting terms with letters and terms without letters as well. Okay, so that's a lot of variation. For the second question, you can see we're linking to perimeter. This section isn't about perimeter, but we're making that link to another area of mathematics. It will be revisited later in the book. Also, we've got the think symbol on this one, and the idea is here we're doing something that we haven't done before, because instead of adding terms, we're subtracting terms. And what's the same? What's the difference with that? Again, I think you can see in number 3 there, we've got another error. Of why is that an error? Really thinking that through. Moving on then to the consolidate section, which is about basically more practice on that. So if students need more practice, they can do it then and there, or it might be something that you choose to do with that consolidation questions. You can see there are plenty of them. It might be something you want to set for homework, or it might be something that you might want to revisit when you come back to this topic at another time, or check 2 months later that they still remember what they had apparently learned earlier by looking at some of the consolidate questions. After consolidate, we've got the exact opposite. We've got the stretch. So the harder questions that will help to deepen students' learning. Okay, so something that needs a little bit more thought. And again, for these sections, we again have in the behind the question section what it is we're expecting there. And talking about the fact that although we don't multiply out brackets in book 1, we do that in detail in book 2, it's something we can explore a little bit here, and you might want to use bar models. So some tips on how to put each of these different sections into practice. Finally, at the end, we've got those reflect questions, getting students to think about what they've learned and to describe how they would do that learning, demonstrate that learning for themselves. Okay, and again, behind the questions says what we're looking for here. We're looking for the key vocabulary, we're looking for concepts, and there's a hint there. Students should use the word coefficient in their answers. We want the idea of the correct mathematical language to be used, so that when you're adding like terms, you only need to add the coefficients of the terms. Would be a really good answer for some of those questions there. So key points in there then, we're supporting a mastery approach. There's one textbook for each year group, and the differentiation is within the content, that we've got some stretch, we've got some consolidation, and the development within the chapter. Linked to the schemes, but can go with any curriculum at all. We don't avoid the hard to teach topics. The entire curriculum is then there. I'm thinking in book 3, there's a lot of work on loci. Loci is something that some books really do skip over. They just go, this is how you draw an angle bisector, without really talking about what we mean about a locus. So we go into depth of all of those. Again, going back to our aim, making sure students understand what they're doing, really looking at fluency, reasoning, and problem solving. And importantly, the books build on each other without the assumption that if you're doing book 3, you know everything that's in book 1 and 2. In the equation section in book 3, there is some work on one-step equations and two-step equations before we get on to really complex equations with unknowns on both sides, just reinforcing that earlier work as well. Okay. Just finally, before I pass over to see if you've got any questions for me, another few words about the teacher guides that we call Behind the Questions, which do exactly that, explain what the questions are. So we give a quick rationale for each chapter, linking where it's come from and where it will be going next. It goes through in details the models and representations, as I showed you as we were going through the chapter. It highlights what possible misconceptions might be. It looks at this idea of interleaving for revisiting things and providing both examples and opportunities for that. And then we analyze each of the questions in the section, sometimes 2 or 3 questions at a time, because they're the same sort of questions, but giving a little bit of further advice on what you might want to use, how you could support students with it, and how you could stretch students with those questions. What's important about this, it helps you really make it your own for your class. You can then really think about which bits you're going to use, which bits you need. If you do buy the Behind the Questions teacher guide, then you also get an editable digital version, so you can make notes where your class was successful, whether it's less successful, when you might want to go back to some of this material again. So next steps, I've already told you the dates there. If you haven't already, then please do sign up for a free evaluation pack. There's the link for that, which I'm sure one of my colleagues from Collins will put into the chat box for you to be able to get that from. And they will be able to answer questions for you now or afterwards as well about details of getting ebooks, copies, and different licenses and packages you can use. So I hope that's been useful. I hope that's covered the key things there for the textbook and how it works alongside White Rose or any other schemes. Thank you very much for your attention. And yeah, I'm ready now to take any questions that you may have. So I'll pass you back over to Charlie.
Excellent. Thank you very much, Ian. Before we move on to the questions, I just want to reiterate what I said at the beginning. So we will be making a recording of this, so we'll be sending that out to you in a few days' time. If you want to share it with any colleagues or anyone that you think will find this of interest, please do so. And we'll also be including an attendance certificate if you want to download that as well. That will come in the email in a few days' time. So let's go on to the questions. So one person has said, I really like the rationale for each question and the explanations for each of the answers. I understand 2 of the GCSE paper calculators can be used, but I didn't see working outs on the slides you showed. So is there working out shown for complex questions?
Yes, there absolutely is. I mean, in terms of the examples I was looking at really were the algebraic ones, and the purpose of those ones was for using calculators in order to do the substitution there. But if you go further into the book, when you get into the addition and subtraction, we go through all multiplication and division as well. As far as long division, we do go through step by step again how to do those, how those calculations should be set out, what the possible misconceptions are, what possible errors are made with those methods as well. So yes, we do show exactly what calculations you need. I think in those particular examples that we had, there weren't any complex calculations involved, but where they are involved, yes, we definitely do that.
Excellent, thank you so much, Ian. And I know that you commented on the slide before, I forgot to mention that if you do want to get in touch with us to trial any of the books that you've seen here, then do contact us at collins.international@harpercollins.co.uk. My colleague will post that into the chat box now, so you will have a contact for us directly for international schools. Another question we've got is, it's quite a generic one actually. So you mentioned that there is the need for use of calculators at this stage in UK curriculum. Do you think it will be useful for students in the future to use them? He said in Cyprus they allow students to use calculators, but only when they start at the IGCSE or the GCSE syllabus level.
Yeah. I think personally that, you know, the sooner the students are comfortable with using the calculator, then that will make it an awful lot easier for them to use them using the IGCSE. You don't have to use a calculator in order to access the materials we've got in book 1, book 2 and book 3. Yeah, you can do it all by using longhand methods if you want to. But, you know, our advice would be that when you're focusing on a particular area of mathematics, such as, say, that algebra, then the important thing is that they understand the algebra and that we're not overloading them with the arithmetic at the same time. So that if you do use a calculator, then that will speed up that time that you need to do those algebraic questions, and it will, you know, really focus their mind on that particular skill that we want from that particular section of the book. So you can use them. It's by no means compulsory. Some of the questions are chosen to deliberately suggest you should use the calculators in there. The next one is for you, Charlene. I think, are home learning tutors allowed to request an evaluation pack?
Yes, I can see that. I would say yes, do get in touch with us. The email address is in the chat box, as you can see. So do contact us and we'll be able to figure out a way of sorting that out for you. So not a problem at all.
Okay, I'll take the next one. So it says, do the year 11 books follow the layout of GCSE? So at the moment, these books are Key Stage 3 focused, not year 11 focused. So we're looking at years 7, 8 and 9. What we do try to do with that, though, is that certainly as you go further up through the years, they get more and more towards GCSE style questions. And I think the emphasis that we've got on that reasoning and problem solving right from the start of year 7 is really, really important, so that when you get into year 10 and 11, it's not just all of a sudden we've got to do GCSE style questions, we've got to do thinking questions. That thinking is embedded right from the start, right from year 7, and it's not an add-on. Quite often in some schemes and some textbooks, that reasoning and problem solving comes right at the end, and it's sort of like, you know, is that little bit extra. And quite often, if you go through something in order, you don't get to that bit, whereas we've got that embedded right through in each of the practice sections and in the consolidate section as well. You know, we've got reasoning and problem solving in there, not just in the stretch, so that everybody's doing it and everybody's doing those sort of things, that the skills you will need for GCSE, even in the year 7, 8, 9 books that we've got at the moment.
Excellent, thank you very much. It looks like the questions are done. I don't know if you'd want to, Ian, leave the audience with something to think about, if that's something you want to do.
I think I would suggest that perhaps, certainly if you get an evaluation pack, if you haven't got one already, have a look at the approach we use in there and think about how does that approach compare to your current teaching? How does the approach I've talked about today and the idea of using representations and models, using different ways of representing the mathematics, how does that fit in with what you do at the moment? And what level at the moment are your students showing of having a deep understanding of the mathematics? Is their understanding the procedural understanding so that they can do a procedure, or can they understand why that procedure works and then be able to use it in another area of maths as well? Because that's the difference that we're trying to make, I think, with White Rose Maths, is that you've got both of those. You've got that procedural understanding, but you've got that conceptual understanding, and you're so confident with the concept that you can use algebra when you're working in probability, etc., etc. So that will be my challenge to the teachers listening this afternoon. Thanks very much, everybody, for your time and your attention. If you do have questions afterwards, then do email support@whiterosemaths.com. We can answer those questions for you if it's about White Rose, or if it's about the books and the purchasing of the books, then you already have the contact details for Collins as well. So yeah, I would just say thank you for your time. Think how it impacts on what you do at the moment, or maybe how it could influence what you're doing and how you might want to change a little bit. And yeah, I hope you find the evaluation packet useful.
Brilliant, thank you. What a lovely takeaway for the end of that. And thanks everyone for listening in, and hopefully we'll see you in another webinar. So take care everyone, and see you soon.